All right, scholars, I have some questions from some of you about the homework, so I want to walk you through a little bit of it, give you about 3 examples to help you maybe give you some knowledge, some enlightenment on the topic, and I'll be quite willing to go over anything we need to in the future, but I thought this video might prove helpful. A lot of this in the homework comes down to this, what I wrote on the board or we kept coming back to in class. Moles are like the central idea to everything. We have atoms and molecules on one side, we have mass on the other. Moles tie it all together. We did examples in our book in class of going from atoms and molecules to moles. We did that. And we did some from moles to mass. Well, since they're all tied together like this, we can go from here all the way to here. That's possible, and that's what some of your homework gets to. You're just going to have to do it while making a pit stop real quick in moles. So if you're going from mass to molecules, you have to stop in moles first, convert to here, then convert to there. Or vice versa. If you're going from molecules to mass, you're going to have to stop in the moles. So keep this in mind, this relationship here in mind. I'm going to show you how to do the first 3 on the homework. So, the first question on your homework is asking you this. It asks about iron fluoride. Iron fluoride. It says, how many molecules are there in 24 grams of iron fluoride? With that in mind, we're going to have to, for going from mass to molecules, just like that diagram I just showed you a moment ago, if you want to rewind the video and see it, or look in your notes maybe from today, we're going to have to go through moles to do this. So we're going to have to turn this into moles, and then go from moles into molecules. Here's how that happens. In order to go from mass to moles, I need to know molar mass. To find molar mass, I have to find the individual molar masses of these atoms. The molar mass of iron, based on the periodic table, right here, lovely periodic table, it says for iron, it is 55.85, and there is just 1 iron atom, so I'm just going to put times 1. You don't have to write that down if you don't want to, it's just there to help you. I like to put it there to keep it visually the same. We got 55.85. Okay, fluorine, this is other one. Fluorine, according to our lovely periodic table, it says is 19.00. We have 3 atoms of fluorine involved in this, so we're going to go times 3. 19 times 3 is 57. We add these up. 5 there, 8 there, 212.85. This right here is the molar mass of iron fluoride. That is what we're going to use in our conversions. So, and I'm going to erase this to make a little bit more room. We'll keep that number though. We need that number. Here's why. We have this. Well, we do some multiplication. We know that 112.85 grams is the same as 1 mole of iron fluoride. I'm going to put these here too to keep it visually the same. How do I know that? Because we added up the molar masses from our periodic table. These magic numbers on the periodic table are the masses in grams of 1 mole of any of these elements. So we took the mass of 1 mole of iron, and then found the mass of 1 mole of fluorine, multiplied it by 3, so 3 of them, and added them up. So this combined substance, this compound, has a molar mass of this. 1 mole of it is equal to 112.85 grams. So look, this cancels now, that cancels there. You need to set up visually like this if you're struggling with keeping your units straight, whether you multiply or divide. This will show you numerator, denominator, same thing in numerator, denominator, it cancels. If it helps, you can put this over 1, because anything can be written over 1. times, now we need to go from moles to molecules. Well, 1 mole of iron fluoride is how many molecules? If you'll recall, the answer to that is Avogadro's number. The number of molecules in a mole is always 6.02 times 10 to the 23rd molecules. All right. Now here, just like we did over there, the moles of iron fluoride cancel. With this iron fluoride one, forgot to write that a second ago. Now we just got a math problem. You can type all this into your calculator. You've got 24 times 6.02 times 10 to the 23rd. I would put that in parentheses in your calculator if you're going to type it in. And then divide it by this number right here. When you do that, when you type it in your calculator, it should come out to something around this. You may round it off a little differently, but I rounded it based on significant figures. There you go, ladies and gentlemen. That is the answer to number 1, right here. 1.3 times 10 to the 23rd. That is the number of molecules in 24 grams of iron fluoride. If I handed you 24 grams of iron fluoride, this is the amount of molecules that you would be holding in your hand. I did not change the amounts. All I did was change the units. We're counting grams here, that's a mass. We're counting actual molecules here. Moles is what let us go from mass to molecules. Moles is what ties it all together. That's number 1. Now I want to show you number 2. All right, so number 2 has a very similar question. It's asking for how many molecules there are in 450 grams of sodium sulfate. So we have 450 grams of sodium sulfate. There we go. Once again, we're going to have to go from mass to molecules. We're going to have to work through moles. To get from mass to moles, we need a molar mass, just like we did a few minutes ago. So we got sodium. Sodium, according to our handy-dandy periodic table, we have a molar mass for sodium of 22.99. Right there on the table. We have 2 of them, so times 2, that's going to give us somewhere around 45.98, I believe. All right, so there is sodium. Next we have sulfur. Sulfur's molar mass is 32.07 on the periodic table. Once again, we only have 1 of those. So guess what? We don't really have to do anything. It makes our math wonderful. Very simple. Thirdly, we have oxygen. Oxygen has a molar mass of 16.00 based on the periodic table. And, oh, I meant not 3. There are 4 of them. 4 of them right here, so we have to put times 4. 16 times 4 is 64. So there you have it. Now, we're going to add these up. It's a 0. Looks like something else, sorry. So we got this. You can type in your calculator as well. It should come out as, somewhere around that. Yep, that's what I got. So there you go. That is the molar mass of sodium sulfate. That is how many grams it takes to have 1 mole of sodium sulfate. Now, we're going to use this number just like we did in the last problem. I'm going to erase our math thing forward. Okay. We got this. We can go times. We just figured out that 142.05 grams of Na2SO4 is the same as 1 mole of Na2SO4. Well, grams of this cancels out. Now we got some more math here. We got to moles. That gets us to moles. Let's get to molecules. We know that 1 mole of Na2SO4 is the same as 6.02 times 10 to the 23rd molecules of Na2SO4. The mole units cancel. Now, once again, we have a math problem. I'm going to go on and erase this. We moved it out of the way already. Use it up here. We're going to do the math now. 450 times 6.02 times 10 to the 23rd divided by 142.05. You should come out with an answer that's somewhere around this. That should be your answer, okay? Or yours may have come out something like this as well. Guys, that's essentially the same number. It's just written a little differently in scientific notation, okay? So, somewhere around there, if you're struggling with getting this in a graphing calculator, you'll probably need to put parentheses around your numerator before you divide it by the denominator. Otherwise, it's not going to interpret your expression properly. So there you go. That's how many molecules are in 450 grams of sodium sulfate. If I handed you 450 grams of sodium sulfate, that's how many molecules you'll have in your hand. Okay, so that's number 2. Right there's our answer. Number 3 is a little easier. Let's go in the other direction, but it's easier. So number 3 is showing you, or asking you rather, how many grams are in 2.3 times 10 to the 24th atoms of silver. Okay? We're going this time from atoms to grams. And so we're going to have to, once again, go through the step of going to moles. Well, let's watch this. 2.3, wait. Sorry about that. I don't need to rewrite it. It's already right here. 2.3 times 10 to the 24th atoms of silver. We're going to multiply like this. We know, based on what we've seen today, that if we're going to moles, 1 mole is the same as Avogadro's number of atoms. So, 1 mole of silver is the same as 6.02 times 10 to the 23rd atoms of silver. Okay? We cancel our silver atoms. What we have left is moles. That's not what it's asking for, though. It's asking for grams. So we need to go from moles to grams for silver. We know that 1 mole of silver is the same as, oh wait, we didn't look up yet what the molar mass of silver is. Luckily we have a periodic table. It says right here the molar mass of silver is 107.87 grams of silver. Guys, I didn't do all this work over here because this time we're only dealing with 1 element, silver. It's not a compound, nothing complicated, just 1 element. Makes the math a lot simpler. Our moles cancel. Now we just have our math problem. 2.3 times 10 to the 24th times 107.87 divided by 6.02 times 10 to the 23rd. Guys, once again, you'll need parentheses. If you're putting this in a graphing calculator, you'll need parentheses, otherwise it won't read the expression properly. If you type this in, you'll end up with something. Now, you may round differently, but once again, I use significant figures around this. 410 grams of silver. You may have 412 or some long decimal. I just rounded off to significant figures. That seems like a good place to go. It may come out in scientific notation for you. You could say it's like 41 point something times 10 to the first. That's the same number, guys. You can write it differently, but that's essentially this. This is number 3, right here, 410 grams of silver. Now, guys, every other problem on here, I've gone on and calculated out everything, every other problem on here is basically this. Just go back and forth from molecules to moles to grams, and then back again and maybe on some of them. Guys, there's 16 of them on here. I just gave you 3 of them. So if you want to do the other 13, I want you to try those. If you're struggling with it, that's fine. This is still something really new to us. We're going to spend more time with moles on Thursday and in the days to come. This is something, we're going to spend a lot of time on. Moles are a very big idea in chemistry. If you have any questions, feel free to email me. Feel free to come by before or after school. I'll be glad to help you out. I hope this has been helpful today. If not, I'm sorry. We can go over a different way on Thursday, or if you come by before then. Have a great day.